In this lesson, we will understand and learn about parallel and perpendicular lines. Welcome back to my channel, Numerics with Nadia, and let's dive into today's lesson objectives. By the end of this lesson, you guys should be able to define parallel and perpendicular lines. We're going to identify parallel and perpendicular lines using their slopes. We'll also go through how this knowledge can be applied to real-world scenarios. And then last but not least, like always, we'll do some practice. And in this practice section, we will solve problems involving equations of parallel and perpendicular lines. If you guys haven't watched my video on the Ultimate Beginner's Guide to Slope, where we went over and introduced slope, I would highly encourage you guys to watch that video as well as the other videos we've gone over involving slope, linked right here. Please pause this video if you haven't watched those. Go ahead and watch them and come back. And once you've done that, we'll get into today's lesson for the day. So we're going to start off by defining parallel and perpendicular lines. And let's start off with parallel lines. Parallel lines are lines that never cross or intersect. And two lines are parallel if they have the same slope. So we have a visual of parallel lines down here on the bottom. And now let's go through and define what perpendicular lines are. Perpendicular lines are lines that intersect, forming a right angle, which a right angle we know measures 90 degrees. And two lines are perpendicular if their slopes are negative reciprocals of each other. So we'll go through and define what a negative reciprocal is, but you can see a visual of perpendicular lines down here in the diagram below. And before we get into our practice section and apply these two definitions of parallel and perpendicular lines, let's go through some real-world examples and applications of slope. So this will occur if you guys are interested in potentially going into architecture, construction, or engineering. It'll be useful in the design of bridges, for example, or road and city grids. So there are definitely real-world applications of parallel and perpendicular lines for those of you guys who are interested in those industries. But regardless, we got to pass our math class, right? So let's get into some practice questions in order to be able to understand these topics and these concepts. The directions for our first practice question says to determine whether the following pairs of lines are parallel, perpendicular, or neither. So we have two equations here. The first one we're given is y equals 3x plus 1 and y equals 3x minus 4. So using the definitions that we just went over for parallel and perpendicular lines, we want to see if these two lines are parallel or perpendicular. So we're going to look at our slopes. We have 3 and 3. So it looks like our slopes here are the same. Knowing that we have the same slope would make these two lines, or this pair of lines, parallel. So that's all we need to do for this first one. We're just looking at our slopes. We're just going through the definition and determining whether the lines are parallel or perpendicular. And in this case, since our slopes are the same, they are parallel. Now we'll get into our second practice question. For number 2, we are given another pair of lines. We have y equals 2x minus 3 and y equals 1/2 x plus 5. So looking at the slopes here, we know they are not the same. What we have to determine though, we know perpendicular lines, their slopes are negative reciprocals. So let's go through here and first off define and go through the process of figuring out if something is a negative reciprocal. So looking at our first slope, it is 2. We know 2, if we wanted to put that in fraction form, is just 2 over 1. The reciprocal, all you do is you just flip your fraction. So if it was 2 over 1, our reciprocal is 1 over 2. And now what we need to do is find the negative reciprocal, so we would just add a negative sign. When we do that, we get negative 1/2. If we go back and look at our pair of lines, we have 2x, or slope of 2, and then negative 1/2 x. So now that we've gone through and determined that the negative reciprocal of 2 is negative 1/2, we know that slopes are negative reciprocals, which would make these pair of lines perpendicular. So for this one, we know that these two lines are perpendicular to each other. And that wraps up our basic identification type of problems. Now we'll get into a few other practice problems where we will find the parallel and perpendicular equations. So for our second practice question, it says to find the equation of a line parallel to y equals negative 2x plus 6. So we're not given a point here, so we're not going to go through and actually solve for the equation. We're just going to list a few examples of equations that would be parallel to this line. So what does parallel mean? Parallel means that this line would have the same slope. So our slope here is negative 2. Any line with a slope of negative 2 would be parallel to this line. So I'll just write out a few examples, but any equation here would do. We could have, for example, y equals negative 2x minus 10 or y equals negative 2x plus 20. The options are endless, especially if you're not given a coordinate where you want this line to specifically pass through. So these are just a few examples of equations of lines that would be parallel to y equals negative 2x plus 6 because they have the same slope. Now we'll just do one more example. For number 3, it's saying to find the equation of a line perpendicular to y equals negative 5/3 x minus 2. So here, again, we want to look at our slope, but here we want a line that's perpendicular. So what does perpendicular mean? That means that our slope for the line that we are finding right now would be the negative reciprocal. So let's go through and look at our original slope. Our original slope here is 5/3. We want the negative reciprocal of 5/3, which again, we will take what we have. Then to find the reciprocal, we will flip our fraction. That gives us 3/5. And then to find the negative reciprocal, we'll just add our negative sign. So any equation with the slope negative 3/5 x would be perpendicular to this line. So a few examples, y equals negative 3/5 x plus 1, or y equals negative 3/5 x minus 9. Any equation with a negative reciprocal would be perpendicular to this line. And that wraps up our lesson for today. I know that this is an introduction. If you guys want more in-depth or more practice problems, please feel free to comment them down below. If you have any specific problems you would like me to do, go ahead and comment them. If there are any other video topics you would like to see, again, comment them down below. If you guys did enjoy this video, please like it, share this video with a friend, subscribe if you haven't already, and I will see you guys next time.